During the course of a research project, you can generate lots of different kinds of data. According to MIT, research data often presents as one of several types. Observational data is often captured in real time and is irreplaceable. Experimental data can be gathered from lab equipment, and so if you've documented your process well, can be reproduced, but it would still be a pain to have to redo any work. Simulation data often comes from models, and while these models can be rerun, regenerating any data to replace lost information is another time sink. And then you can have derived or compiled data. Often this kind of data can be generated from activities such as text and data mining, which, while reproducible, it's something you really don't want to lose and have to repeat your whole process again. Data can take many forms, from physical paper lab notebooks all the way through to bespoke software and coding that you design for a very specific part of your research process. So how do you ensure that your data is kept safe, well documented and secure so you can come back to it during your project, as well as being able to share it with others as part of a collaborative effort or even as part of the publication process? Storage is key. Depending on what you're working on and how much data you'll generate, will dictate what options you can use. But in this video, we'll give you some general ideas of what to use and what not to use. We could go into lots of detail, but we want to keep this video short, so we'll link to some further resources in the video description to help guide you further. So, let's start with the basics. Physical storage. External hard drives are a pretty cheap solution to backing up data from places like your laptop, so take advantage of this option. However, be aware that hard drives can degrade over time and because of their portability are also very easily lost. So make sure you have a backup to your backup. One thing you could consider doing is seeing if you have storage space within your department. Depending on where you are based, you may well get a small amount of storage on department servers, which are then backed up regularly according to existing university storage protocols. If you are working on something really big that will take up a lot of space, check in with your departmental IT officer to discuss options. You can also take advantage of cloud storage options, but be aware of what data you are storing and where you are storing it. Different cloud storage providers have their servers based in different countries, and depending on what you're working on, as well as who is funding your research, you may have to ensure that you're storing data within the EU, for example. Also, some data can't be stored in the cloud because it needs to be kept somewhere more secure and offline. This is especially important if you're working with lots of sensitive data, so be sure you're not breaching any data restrictions before uploading to the cloud. The University of Cambridge has lots of advice on what can and cannot be stored online, as well as what cloud options it supports, so we'll put some links to that information in the description. If you are working with lots of physical data, such as paper-based lab notebooks and other non-digital items, make sure you regularly convert them into something you can save in a digital format. A great cheat with notebooks, for example, is to take photos of pages and save those photos somewhere safe, so if anything happens to your notes, you have a copy stored away. When making decisions about what data to keep and where to keep it, ask yourself this series of questions. How much data would you lose if you lost your backpack with your laptop and external hard drive in it? You left your USB stick in a PC in a library somewhere. There was a fire in your lab. Your flat was broken into. A small child got into your cloud storage because you left your computer open and started deleting files for fun. These are all real-life examples that have happened to people and organisations, and sometimes it meant that they lost years of work in one instance. So, our advice would be this. Have at least 2 backups of your research at any one time. How regularly you back these up will depend on how much work you can afford to lose. So if you need to back up monthly, weekly, or even daily, build this into your work schedule. Keep one of your backups at home, say using an external hard drive, and then one at the office, whatever this means for you. And then have a backup on a portable storage device, so you can move data from place to place with ease. When backing up your work, make sure you have a file structure that makes sense, so you can come back to it later on in your project and still find what you need quickly. If you're working on something over several years, you might forget what that final.doc file actually is, so make sure your file names are meaningful and consistent. This is also useful if you're working in a lab group and you need to share your work with others, as well as preparing your work for final publication. Keeping your work safe, backed up and consistently documented means you can trust that you can not only find what you've been working on as quickly as possible, but you can also use it to communicate your research to others in a clear and reproducible way, which is always a good thing. So take some time to think about what your data management process should be, and maybe even write a small plan that you can refer back to As your research evolves throughout the duration of your project, trust us, it'll be worth it in the long run.